So for our second stop of this field trip, we've now moved up section. So these are the sort of middle-aged units here. Looking at here across from Highway 24 near the Caldecott Tunnel, we're looking at two specific units. The first is the Orinda conglomerate, which you can see here as this sort of gray-blue bed. And we're going to go up closer to actually see the class within this unit. But if we look immediately up section or to the right of this, we can see a red oxidized unit that's just above it. And this is the Moraga basalts, which is part of the Grizzly Peak group. And these are both Miocene-aged units, approximately 9 million years old. And as we can see here, they're similarly steeply dipping, but not quite as much as the Claremont Formation. And the big thing I want you all to take away from looking at this today is the difference in energy environment between the Claremont Formation that we looked at, which we determined to be marine based on the very fine grain size and presence of shale and chert, to this conglomerate, which likely has a fluvial source to this. So now we're moving up and out of the ocean, indicating that there's some sort of tectonic activity happening, but we also have this interesting basaltic unit that may provide further evidence of this continental deposition for this unit. So let's go up closer and take a look at these clasts. Okay, now we've moved up closer to the outcrop of the Orinda Formation, right off of the off-ramp for Highway 24 here. And now we're actually up close and personal with the outcrop, so we can see the fairly coarse grain size of the clasts here. And a big thing I want you all to look at, as pointed out in your lab, is there's a variety of different clasts here within this conglomerate. So let's make some observations about the general angularity, the size distribution, and potentially the composition of this unit. So first off, we can see that this is a pretty poorly sorted unit. We can see a variety of grain sizes from this very large, tens of centimeter across metamorphic clast here, but then we can see some smaller pebble and gravel sized grains. If we actually zoom in, we can see sort of the variation in grain size within this conglomerate. And we can also see a variation in the degree of rounding, likely telling us how far some of these have been transported. So this volcanic clast here is fairly subangular, but there are a few rounded ones as well. Some of the metamorphic clasts, specifically this sort of bluer color clast that we can see here, are much more well-rounded. So in this environment, these grains have been transported some distance away from their original source and have been rounded as a result of some sort of fluid transport process, most likely riverine or fluvial, to form this conglomerate about 9 million years ago. So in looking at these units, you've seen looking at some of the clasts represented in this, some of these should be somewhat familiar to our metamorphic lab, where we looked at a bunch of different stuff. So starting here, we can see this sort of greenish unit here that looks very similar to a snake skin type texture. So this is an example of a rock known as serpentinite, which is, or serpentine, which is the state rock of our beautiful state of California here, and it's actually quite abundant within the Orinda Formation. This is sourced from one of the units we're actually going to look at in the Point Reyes field trip, which is known as the Franciscan Complex, and is indicative of the subduction zone environment where these type of clasts were formed. Now, to be clear, this clast is far older than the units it's encapsulated in, but it's been eroded away from some source to the west in the Marin Highlands that was deposited about 9 million years ago within this unit here. But we also see some really amazing blue colored rocks here within this conglomerate, and that should get you thinking about another rock that we've talked about quite frequently, both in the Metamorphic Rocks lab, but also in the lecture and even on the midterm, that's very well known to be related to subduction zone environments. So the bluish type rock that you see that's sort of prevalent within this has a very distinct formation location in terms of its temperature and pressure. And so you should start to think about the rock that we've talked about quite regularly as an indicator of a subduction zone environment. That's also one of the common clasts that we see here. But you can see a variety of different clasts as we go through, from some gray wackies, which is a sedimentary rock. We see some volcanic units here represented, and in a few places we can actually see some chert. But again, we see a mixed bag here of a representative sample of all the lithologies that were around when this was deposited, from metamorphic to sedimentary to volcanic. And we're actually going to make our move up the section here to go take a look at the Moraga basalt up there. But what I hope you guys take away from this is that there is a very coarse-grained, rounded to sub-rounded conglomerate that's likely indicative of some sort of braided stream or fluvial environment. And if I encourage you all, if you have the time to come out and take a look at these, to really put your face on the outcrop and see the variety of grain sizes and shapes to get an indication for the type of system that deposited the Orinda Formation. So let's go move up to the contact between this unit and the Moraga basalts to see what we can see about that contact. So now we've moved from where we were just there on the bottom of the outcrop near the road up to the contact with this dark red unit here. And as we take a look at this, we can see it's quite a bit different from the very coarse-grained conglomerate immediately to the left of us here, which is the Orinda Formation that we just took a close-up of, to this more reddish unit here. And if we actually take a look at it, we can see this highly vesicular, fine grain or aphanitic surface that is actually indicative of the Moraga basalt. So here we can see the contact of the Moraga basalts, which was deposited directly on top of the Orinda Formation. So here, if we were actually able to dig down to the contact, which is covered by vegetation, we would actually see what's known as a baked contact, where the contact with the Orinda is actually altered as a result of heating from the Moraga basalt. So again, here is the contact with the Moraga Formation. If we actually look across the way here onto Highway 24, we can see this sort of terraced structure here that's a man-made feature, where we can see a similar relationship with the Orinda Formation to the right, with the Moraga basalts immediately to the left of that, mirroring our current location across the highway with the Orinda. So I'll go down lower here so you can all see and get a better feel for the scale of the contact. But a big thing to notice here is this is a conformable contact, likely indicating that the Orinda and the Moraga Formation were deposited conformably relative to one another. So stepping down from where we just were up there, right above the Orinda, you can see more clearly here this difference here between the clastic or sedimentary sourced Orinda Formation and the Moraga basalts more clearly here. That's actually quite prevalent from some of the photos that Zaman will be providing along with this lab. And again, just to prove, or just to show the continuity across layers here, we can see the similar thing in this road cut directly across from us on Highway 24. This is actually fairly apparent as well from the street view image you have, so this should be enough for you to plot approximately on your topographic map where this contact is relative to the field stop on Highway 24. So please use the information available in your handout along with the Google Earth image to approximate where this contact between this lower Orinda, so the older Orinda unit, and the younger Moraga basalts will be to answer that question in your lab.